Just waiting on everyone to join in. I guess they do have a few more minutes. Good morning, good morning, good morning, Cameron. Good to see you. Hopefully we'll have a good turnout. We'll see. They got a few more minutes to slowly get themselves out of bed. Speaking of which, yep, mine's made. I woke up a little chilly this morning, so I'm wearing my big comfy coat. All right, I guess I'm gonna mute myself for just a minute and give everyone a little more time to log in. I usually start about 5 minutes after posted time to give people a chance to get a drink or whatever. I did send out the reminder about an hour ago. So hopefully we will get some more shows. Morning, Tana. Good to see you.
Good morning.
All right, I'm an AFK for just a minute to check on my little one before we get rolling here. So I'll be right back.
Yo, this man just up and disappeared. Like, where'd he go? Oh, Smith.
I apologize for that loud, obnoxious noise, but I actually played it on your screens. So we are going to get rolling. Welcome. If you are joining us later on the YouTube, today we are going to be going over, I believe, equations with variables on both sides, and also, yes, equations with variables on both sides, and also equations with parentheses. So I've got a ton of info linked up on Classroom for you guys to please read and review and watch and listen and enjoy. But for those of you that are just going to stick to these videos, you're more than welcome to practice, pause, and try to get your answers before you watch me work them out. If you have any that are really stumping you, please screenshot them and send them to me. You have 2 assignments posted on Classroom that are due by Thursday, not Friday, Thursday at 3 p.m. If you want me to give you some correction notes so that you can try the ones you missed over again, have them done by Wednesday at 3 p.m. So with that, let's get right into it. Okay. So here's the first kind of problem we're going to be doing. We're going to be solving for a missing variable. Now, the goal here is just to figure out whatever S is equal to in this system. That was a weird pop-up. Okay. So in this system right here, we have 8 minus 4s equals s plus 13. S is going to be equal to something, one value. And our goal is trying to figure out what that value is. So it's your job to figure out how to do that. Okay, so let me get my math practice standards out. I hate it when I forget to get those loaded. 1 second. Apparently I hid my picture. Give me one more second. If I can't find it, we'll just have to do without. There it is. Get in there. Okay, here we go. Okay. So in this system, what we know is that there is an S. And even though it's on both sides, it's right here and also right here. So even though it exists on both sides of the equation, it is only equal to one value. And that's our job, is to discover what that value is. So we've made sense of the problem and what we're being asked to do. Let's go ahead and get started. So if you're working this out on your own paper, what you want to do is first just write down the equation 8 minus 4s equals s plus 13. Now, there are two primary abstract rules that we're going to be abusing right now, and those are these two things. So anything that you are adding or combining with its opposite is going to be equal to 0. That's our first abstract. So reason abstractly, math practice data number 2. That's the first thing we're going to be totally abusing, is that anything added to its negative or its opposite will be equal to 0. And the other one is going to be anything divided by itself is always going to be equal to 1. So we're going to go back to those in a second. So let's just get some work done. Okay. So the goal here is to get S by itself. Like we want to end up right like this is right here, like S equals stuff. To do that, we're going to try to get all the variables on the one side of the equation. Now I've got negative 4s on this side and positive s on this side. So because I prefer to keep things positive, I'm going to go ahead, I'm going to do the opposite. I'm going to add 4s right here onto the left side of the equation. Now, the reason I'm doing that is because of this abstract rule. I want to make this into nothing. So now, of course, if I do that to the left side of the equation, I also have to do it to the right side of the equation. I'm going to have to add 4s to this side as well. Hey, Luger, thanks for joining us. So another thing I'm going to do, because I'm moving all the s's to the right side of my equation, I'm also going to do an inverse where I'm going to subtract 13 from both sides. So here's what happens. 8 minus 13 8 minus 13 is a negative 5. You might be thinking, well, that didn't really help us at all, but you'll see why in a second. Now, negative 4s plus 4s, again, that's that abstract law. That cancels out. That makes it 0. And negative 5 plus 0 is still just negative 5. So I added the opposite there on purpose. Now, s plus 4s, remember, when you see a variable s, that's the same as adding 1s. So 1s plus 4s is 5s. Now, here's another abstract moment. So positive 13 minus 13 equals 0 again. So basically, on both sides of the equation, I have a plus 0. But I am so epically lazy as a math person, I'm not even going to bother writing them down most of the time. So, can't stop yawning. So I've got -5 equals 5s. So then we do the other abstract law. This one. Anything divided by itself is equal to 1. So since I want s by itself, I'm going to divide by 5. But since this is an equation, I have to do to both sides of the equation. So I will divide both sides by 5. So this is where the abstract law comes into place. 5 divided by itself is equal to 1. So this is basically equal to 1s. And -5 divided by 5 is equal to -1. So apparently s would be equal to -1. So what else did we do there? We modeled our mathematics. We attended to precision. We're very careful with all of our mechanics. I like to think the structure that we use is this sort of, I'm going to line everything up. I'm going to use the equations. I'm going to use my abstract laws and keep things nice and organized. And going forward, we'll be using math practice standard number 8, where we're going to be using repeated reasoning, because if it worked the last time, it should work on future problems that look very similar. Okay, so let's try another one. That's gonna make me click this button again. Hang on. Really? Okay, apparently it wants me to open up a whole new window, which is fine. Second verse, same as the first. Okay. So we were trying to solve for a, and again, in this system, a is the exact same value on the left side of the equation as it is on the right side of the equation. And it's your job and my job to figure out what a would be equal to make this system work or make it into a true statement. So again, our system's right here. Our variable a is on both sides of the equation, which is fine. I see on the left side and the right side. So we've made sense of what we're being asked to do, and our abstract rules are going to be that anything plus its opposite is equal to 0, and that anything divided by itself is equal to 1. Those are the two abstract laws we're going to be using here the most. Let's go get rolling. First thing you need to do is write down the equation for yourself. So 5 plus 14a equals 9a minus 5. So on your own paper, that's what you'd have written down. Now, we can't combine any like terms because this 5 doesn't have an a, the 14a does, and you can't combine unless they both have the variable of the same power. So what we're left with is what we call inverse operations, and that is these laws down here. So what can we do? Okay, so we want to get all the a's on one side of the equation and all the constants, those are the numbers with no letters on them, to the other side. So what I'm going to do here, to keep things positive, I'm going to subtract 9a from both sides. So this is me using repeated reasoning because I remember this worked on the last one, and I'm making use of my structure. So let's see. Oh, also, since I'm going to be having all the a's on the left side now, I'm going to go ahead and take away 5 from this side. And if I take away 5 from the left side, I have to take away 5 on the right side. So 5 minus 5 is 0. 9a minus 9a is 0. So what are we left with? Well, if 5 minus 5 is 0, well, 14a minus 9a is 5a. 9a minus 9a is 0, and negative 5 minus 5 would be negative 10. Negative 5 minus 5 is negative 10. Okay. So then if we were, again, to abuse the abstract rule, if we're to divide both sides by 5, which we can do, 5 divided by 5 is 1, so you end up with 1a, which is, just a. Negative 10 divided by 5 is negative 2. So a would be equal to negative 2. Sweet. Sweet. And we would have only gotten there if we had really attended to precision. I like how we model our mathematics. We're almost making an argument that we're proving to ourselves that the math is all right before we hit that check mark. Awesome. If you have questions in chat, if you have questions, those of you that are here live, feel free to sound off in chat, like, hey, where'd that 3 come from? Or why are you crossing things out with that red line? Or et cetera, et cetera, et cetera. So since I've done a couple now, I'm going to put one on the screen here. I want you guys to try this. If you're watching on YouTube, pause it, see how far you can get with the problem until you might need help, and then I'll catch up to you and we'll see how things work out. So let me load us up a new problem. Okay, here it is. Here is our system. So we're trying to solve the letter K, and that variable represents one value. So other than me writing down the problem, I'm going to give you guys a couple minutes to try and figure it out. So it starts off with 20 minus 6 plus 4k equals 2 minus 2k. 20 minus 6 plus 4k equals 2 minus 2k. Okay. So there it is. I want you to start, see how far you can get without any help. And if you're watching this on the replay, pause it now, work it out, and see if your solution is the same as mine in just a minute. Sound off in chat when you feel like you got an answer. Okay, well, I'm going to start catching up and we'll see how we line up. Now, I'm going to notice right away that there are some like terms here I can combine before I do anything. This 20 minus 6, neither one of them has a k attached to it, so you can go ahead and combine those. Well, 20 minus 6 is 14. So what we start off with is really 14 plus 4k is equal to 2 minus 2k. And now this is where we're looking at inverse operations for sure. So if I were to add 2k onto both sides, now no one tells me to do this. My own intuition is what's telling me to do this, because I'm basing this on all kinds of repeated reasoning. I've done this so many times, I automatically know that I'm going to want to add 2k to both sides. See, now I could have taken away 4k from both sides, but then I'd be in negative numbers, and I'd rather just stay positive if I can engineer it that way. Now, since my k's are all moving to the left side of the equation, I'm going to go ahead and I'm going to take away 14 from this side and take away 14 from this side. As far as the constants go, those are the numbers without variables. So let's see if those opposite inverse operations worked out. So 14 minus 14 is 0. 4k plus 2k is 6k. 2 minus 14 would be a negative 12. And negative 2k plus 2k. So negative 2k plus 2k, that makes it 0. Oh, where's my red? So yeah, we're only left with 6k equals negative 12. So now the last thing we're going to do, if we divide this side by 6 and we divide this side by 6, some interesting stuff happens. 6 divided by 6 is 1, so we end up just left over with 1k. Negative 12 divided by 6 is a negative 2. So I'm hoping the answer is just negative 2. If 1k is equal to negative 2. Hey, it is. Sweet. I hope everyone was trying that at home got that one right. So let's try another one. Again, we're going to start off by making sense of this. It just says solve for A. It gives us this equation. So that's as much making sense of it as you're going to get. So now we need to reason abstractly and do those inverse operations. So the first thing we're going to do is write down our problem. A minus 15 equals 4a minus 3. I had to look back at it, double check, make sure it's correct. I would hate to miss it because I wrote down the equation wrong. Okay, so the first inverse operation I'm hoping you noticed is that if I just take away a, oh, that's horrible. Let me back that up. Okay, so this is really 1a. So if I take away 1a from both sides, the a's will stay positive because 4a minus 1a is going to be 3a. And of course, 1a minus 1a is nothing. So that worked out. Now, the other issue is these constants, these whole numbers. So since all the a's end up on the right side, I need to move all the constants to the left side. So let's go ahead and let's just do the opposite over here. Let's add 3 to both sides. So when you work this out, first of all, 4a minus 1a is 3a. It works. It's done. But negative 15 plus 3, that'd be negative 12. So when you divide by 3, then this thing happens. 3 divided by 3 is 1. So negative 12 divided by 3, and here we go. Negative 12 divided by 3 is negative 4. And that's equal to a. Or, well, 1a, but who's counting? So let's see if that worked out. Come on, keys. Sweet. Okay. Unless someone chimes off in chat with a question or a concern, I'm ready to move on to the next step. It's going to be a lot of the same stuff, except we're going to add in some parentheses. That's it. Checking email to see if anyone has sent me a screenshot of a problem I want to see worked out. No. Mm-mm. Nope. No screenshots from any students yet. So anybody in chat have a question? If you do, please sound off. I'm going to load up the next skill. Okay. So let's recap what we've been doing so far. We've been noticing there are variables on both sides. It's the same variable, it's just on both sides. We realize that we've got to find out what it's equal to. And to do that, we combine some like terms. We do inverse operations. Those are those abstract rules like subtracting the same value so you end up with 0, or dividing by the same number so you end up with 1 as a multiplier. And then by carefully engineering it, we end up with an answer of like A equals number, or S equals number, or B equals number. And that's your whole job. Now, this next part of the lesson adds in one step to that with parentheses. Okay. So here we go. So this is going to look very similar to what we were just doing, except in this case, we have these parentheses just staring back at us. So let's take a look-see. Okay. So here's the problem that we're going to have to make sense of. The first thing I want to do, pretty much always, kind of like on auto response, is write it down. So 7h equals negative symbol, parentheses, 2h minus 18. I'm going to put a little space right here for a reason. Okay, so the first thing we need to understand is that when you see a negative symbol up against parentheses, what that's really saying is you get a -1. That is a horrible one. 1 second. Let me try that again. A little better. So when you see a negative symbol outside a set of parentheses, that's like saying a -1 is right there as a coefficient. Like it's the number you're multiplying by everything on the inside. So what you'd end up with here is 7h stays, so we haven't done anything to it yet. Now you have to distribute this -1 into both terms. So -1 times 2h is -2h. Yeah, -1 times -18. Oh, this is negative times a negative. -1 times it. Let me highlight that. It's right here and right here. So it's negative times a negative. All right, so -1 times 2h is -2h. -1 times -18 is plus 18. Now we can do some inverse operations. So you might notice that -2h and 18 don't have anything in common, but if I were to add 2h to both sides, what do we get? Well, 7h plus 2h would be 9h. -25, I'm sorry, -2h plus 2h. That's where our abstract cancels. Okay, that makes 0 plus 18. So 9h equals 18. Okay. So last step, divide both sides by 9. The reason we did this is not because someone told me, it's because I saw 9h and I said, oh, if I want h by itself, I've got to divide by its coefficient. So 9 divided by 9 is 1. So now I've got 1h. 18 divided by 9 is 2. So apparently in this system, yeah, h is equal to 2. Okay. So the parentheses added out one little step in the beginning. That's about it. Let me clear all this away. We'll try one more before I let you guys go try one on your own. Okay. So let's go ahead and make sense of this. Okay. So let's make sense of this problem right here. Let's make sense of it. I think the best thing to do is to write it down first. That'd be negative t equals 9 parentheses t minus 10. Negative t equals 9. Yeah, okay. So just like the last problem, the first thing we've got to do is this. Let's see. Right here. This 9 has to get multiplied by both terms on the inside of the parentheses, both parts of the binomial. So this negative t is just chilling. I haven't done anything to it yet. Now 9 times t will be 9t. And negative 10 times 9 will be negative 90. Negative t, 9 times t is 9t, 9 times, yeah, that's right. Okay. So now what I want to do to get this moving is the opposite of something. So the opposite I would like to do here is probably, now usually I try to avoid negatives, but in this case, it's just going to happen. So if I subtract 9t, sorry, just checking in a message from the other 8th grade teachers. Okay, so if I take away 9t from both sides, here's the magic that happens. And the more of these you do, the easier this gets. I promise. It becomes just so muscle memory. You just automatically are doing it. So 9t minus 9t, that's the 0 we wanted to make. Done. So now what we end up with, negative t, that's negative 1t minus 9t. So now we've got negative 10t. It's negative, but we'll be all right. And we still have this negative 90. So now what we're going to do is we're going to divide by negative 10 on both sides. So negative 10t divided by negative 10, well, anything divided by itself, remember that abstract rule? Anything divided by itself is just equal to 1. So basically, that gives us 1t. And negative 90 divided by negative 10 will just be 9. Negative divided by negative is a positive. So t should be equal to 9. And it is. Sweet. Let's do another one. No, actually, you guys need to try one. Okay, so I'm going to give you guys a minute or two to try and solve this, or at least get as far as you can without any extra help. Here's your problem. We're trying to figure out what b would have to be equal to make this whole sentence make sense. The first thing you want to do always is write it down. So it'll be 3 minus 2 parentheses b minus 2 and parentheses equals 2 minus 7. 3 minus 2 parentheses b minus 2 and parentheses equals 2 minus 7b. Yep. Just keep in mind there's a b there. and there's a B there, and they're still going to be equal to the same thing. So take a minute, get as far as you can with that help, and then I'll help you finish. Go, 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 go. Okay, I'm going to jump in and give you the first step. Let's see if it pushes you in the right direction. So I would love to combine like terms, but right now I can't. So what I am going to do is take this -2, and because it's up against the parentheses, it has to distribute and get multiplied by both of these terms. So that you'll end up with 3. Now -2 times b would be -2b, and -2 times a -2 would be +4. And that's equal to 2 minus 7b. Okay, so I've done the distributive property. That's your first step. Okay, now go ahead and see if you can figure out the next step, and then I'll help you out in just a second. Okay. Oh, it's no problem that you're late, man. That's why it's gonna be on the YouTube later. So if anyone missed anything, they can watch it from the beginning. Okay, so let's see if you guys did what I would have done. So the next thing to do for me is Okay, right here, there's a 3 and there's a positive 4. Those are like terms. They both don't have a letter on them. So 3 plus 4, that's 7. So we would end up with 7 minus 2b equals 2 minus 7b. So those combined terms, okay, we're done. Now we've got to do some inverse math. Okay, so now what I want to do, if I were to add 7b on both sides, it would end up positive. So I think that's what I want to do. So I'm going to add 7b on both sides of the equation. And then if I take away 7 from both sides, let's see how that works out. Let's see if everything cancels the way I thought it should. Okay, so 7 minus 7, that makes 0. Negative 7b plus 7b, that makes 0. So what do we end up with? Well, negative 2b plus 7b is 5b. Okay, so negative 2b plus 7b is 5b. And then 2 minus 7 is a negative 5. 2 minus 7 is negative 5. So then, last step, if we just divide 5b by 5, what we end up with I'm pretty sure b is going to be equal to negative 1. Because if we divide by 5, that makes 1b. And negative 5 divided by 5 should be negative 1. Okay. Right on, it worked. Yep, chat. Someone did get it before I did. Very nice, very nice. So I'm hoping these skills are starting to click, because it's just muscle memory. Once you do like 4 or 5, 10 of these, you can just crank them out so quickly. All right, so check this one out. That's not what I meant to do. There's your timer. See if you can post your answer in chat before that timer goes off. Go, 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 go. S is equal to what? Okay, I'll give you a little help. Let me pause this. Okay. So just in case you were wondering, the first thing you should do is write it down. So it'll be 2s plus 4 equals 5 parentheses negative 4 minus 2s, something like that. 2s plus 4 equals 5 parentheses negative 4 minus 2s. Okay. So other than writing it down, my one hint to you is that the first thing you would do is see if there's like terms to combine, and there are not. There are no s's or numbers we can just add together, but what we can do is take this 5, because it's up against the parentheses, and we can multiply the binomial, the two parts on the inside. So what you end up with, this 2s has not been messed with. The 4 has not been messed with. Now 5 times negative 4 is negative 20. 5 times negative 4 is negative 20. And then 5 times a negative 2s would be negative 10s. So 2s plus 4 equals 5 times negative 4 would be negative 20. Okay. 5 times a negative 2s would be negative 10s. All right. Okay. So I'm going to start the timer back up. See if you can finish it from there. All right, there's your timer. So sound off in chat if you think you got it. But here we go. So yeah, okay. So then the next thing I would do to try and keep things positive, I think I would go ahead and add. Yeah, I would add 10s to both sides. I always line up the variables with the other variables, if you hadn't noticed. And then if I'm moving the s's to the left side, I'm gonna go ahead and have to take away 4 from both sides. So all the constants are on the right. Okay. So what do we get? That means the 2s plus 10s, that's 12s. And of course, 4 minus 4, that's 0. We've been doing that all day. That would also brings me to negative 10s plus 10s. That's going to make it 0. So negative 20 minus 4 would be negative 60. Okay. So now the last step, we can divide both sides by 12. So 12 divided by 12 is 1. So I ended up with 1s. And negative 60 divided by 12 will be negative 5. At least I believe so. Okay, so I must have goosed something. Let's see. I learned from mistakes. What did I type? I typed negative 5. Okay. So negative 60 divided by 12 should be negative 5. 15, yeah, that's right. So what a goof. Oh, I would love it, chat, if someone noticed it before I did. All right, 2s plus 4 equals 5 parentheses negative 4 minus 2s. Okay. So 2s plus 4 equals negative 20 minus 10s. That's right. So if I add 10s to both sides, 12s. Oh, I see it. Anybody notice? Look right here. So, let me draw it for you. Okay, so look right here. So I subtracted 4 on the left side, but for whatever reason on the right side, look what I did. I subtracted 40. Why? Dirt. Okay, so let's just see if I can back this up. I'm still going to be dividing by 12. That's not the issue. But what should have been right here. All right, so if I just subtracted 4, now negative 20 minus 4 would be negative 24. Okay, so negative 24 divided by 12 would be negative 2. Let's see if that reconciles better. Okay, so whatever you do to the left side, make sure you do the right side, and don't have a moment, an old man moment, where you just do multiples of those numbers. Okay. One more. Unless chat shouts at me for a specific question, I'm going to do one more and we're going to call it a day. Go back to it. We should probably do one. Yeah, let's go ahead and do one with decimals in it. Yep. That's what we'll end it on. We'll end it on one that has a good old-fashioned decimal in it. All right, it's the same skills we've been doing, except this time I just have to worry about a tens place, it looks like. Okay. So let's make sense of the problem. So I'm supposed to be solving for C in this system. Okay. So I've made sense of what I'm trying to do. Check. Let's go ahead and write it down. So 2/10 times in parentheses times 10 minus 5C in parentheses equals 5C minus 16. Okay. So nothing has changed about the mechanics here. Yeah, chat, I'll do this real quick and then I'll look at one like that. So if I had to multiply 2/10 times these, well, 2/10 times 10, anytime you multiply by 10, it moves the decimal over one place. So 2/10 times 10 is 2. 2/10 times a negative 5C. Well, 5 times 2/10 is 1. This would be negative. So that'd be negative 1C equals, that is a horrible 5. 5C minus 16. Okay. So the next thing I'm going to do is I'm going to add 1C to both sides. And then I will add 16 to both sides. And that is that's me using my repeated reasoning because I know what's worked for me in the past. The abstract rules that I'm about to use. So I'm reasoning abstractly. So basically, negative 1C plus 1C, that makes 0. Negative 16 plus 16, that makes 0. And the reason I did that is to simplify what I've got going on here. So 2 plus 16, that's 18, equals 5C plus 1C is 6C. If I divide both sides by 6, then the whole thing should come out equal to 3. It does. Okay, I said that would be the last one, but I did get a request. 5 on the first assignment. Okay, hang on. Let me look at our classroom assignments this week. One like number 5.
Not bad.
Let's see. Classwork assignment number 5. Okay, so I'm gonna go ahead and clear off my screen here. Okay, so number 1, 2, 3, 4, and 5. Okay. Oh, right. Okay. So I'm gonna go ahead and demo this, but this is gonna be the focus of tomorrow's stream, and that is how to determine how many solutions you get. Okay, so I'm gonna make a really simple one. Let's say 8x plus 3 equals 12x minus 15. Okay, so there's 3 possible numbers of solutions. We can have A, no solutions, B, exactly one solution, and C, infinite solutions. Now, without getting into too much detail about what those would look like, here's a picture. Okay, no solutions is when you got 2 lines in a system that are going the exact same direction and they will never touch because the solution is where the lines crisscross. So if the lines are parallel and they never touch, there is no solution. Okay, I'll go into this more tomorrow. Exactly one solution would be something like this. When the 2 lines crisscross exactly once, that's what we say, that is one solution. They cross exactly once. Now, there's another thing that can happen when you have the exact same line. So infinite solutions where you had a line going this way, and you have another line that's the exact same, and that's infinite solutions. But of course, this doesn't really help you because you're given an equation. So let me break it down in another way. Okay, so go away. No. Okay, so here is the way, chat, you want to look at this. So no solutions is when you end up with something like 8 equals 12. Like that is not possible. So it doesn't make any sense. So there's no solutions. Now, one solution looks like this. One solution is where you end up with something like x equals 4 or 5. It doesn't even matter. If you come up with an answer like that, that means you have one solution. It means the two lines crisscross at x equals this. Okay. The infinite solutions is when you get something to the effect of like 9 equals 9, like something that is always true. So as I look at this problem that I just randomly made up, what we need to decide is not really what x is worth. All I want to know is this going to have no solutions, one solution, or infinite solutions? So the way we do that is some inverse operations, stuff we were just doing today. Let's see. So if I were to take away 8x from both sides, and if I were to add 15 to both sides, what would happen? We'd end up with, that makes a 0, that makes a 0. Oh, boop. 3 plus 15, that'd be 18, equals 12x minus 8x is 4x. Okay, so then what we'd end up doing, we divide both sides by 4. So that's equal to 1. So basically, we end up with x equals 18 over 4. And yeah, you could reduce that to 9 over 2, but I don't really care. The fact that it came out to be x equals something means that it has exactly one solution. Yeah, sure, it's a fraction, but anyway, we're going into more detail on those questions tomorrow. So if you're watching this on the replay, please go back and watch the problems we worked out. Practice them on your own, pause, and see if you come up with the same answers we did. If you're going to be here tomorrow, I'm going to be going over problems like this one, which is where you have to learn how many answers an equation or a system of equations would have. So if you have any questions, please screenshot the ones you want help with and send them to me via email. I hope everyone's staying healthy, taking care of their families, taking care of themselves. So until tomorrow or next time, I'll see you later.